Assalamualaikum warahmatullahi wabarakatuh. So we are going to present for our Apex project. For our Apex project, we have choose the force and motion title, and the project we are working on is Mousetrap car. Okay, for now, let's start with the introduction, which will be explained by Satish. Okay, let's move to the slide.
Okay, for the introduction part, we used several scientific principles and laws in our project. We have a car which we would like to put into motion to make it travel far as possible. There are several physics principles and laws that are taking place when our mousetrap in motion. Those are conservation of energy, Newton's law, potential and kinetic energy, rotational inertia, friction, and torque. I would like to explain the most important physics law, which is Newton's law. Newton's first law, second law, and third law are the main focus of our project. So, first of all, Newton's first law states that an object at rest will remain at rest, and an object in motion will continue its motion in the same speed and in the same direction until an external force is exerted. This law is also known as law of inertia. The only problem with law of inertia is this law is assumed that there is no friction. If that were the case, our car would not move until an external force is exerted, such as push, and it would continue its motion until it is stopped by an opposing equal force. But unfortunately, there are few types of friction which takes place when our mousetrap is in motion, such as air resistance, friction from the contact with the floor, and friction from the moving parts of the car. Therefore, the frictions are classified as surface friction, while the air resistance is classified as fluid friction. As distance is our primary target, so our target for the mousetrap is to reduce much friction as possible. Now, my teammate Hanafi will explain Newton's second law and third law.
Alright. Newton's second law states that acceleration is produced when the force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. This is well known by everyone if they don't realize it. Everyone is aware that the heavier an object is, the harder it is to push it, more force in it. From this relationship, we see that the force is equal to mass times acceleration, F equal ma. For our master car, this would mean that the lighter the actual device, the further it will go with the same amount of force. This proves we shall do everything in our power to create a lighter vehicle. This can be done by using a lighter type of material for the body, like this for the wheel, and by removing mass from the wheels. Mousetrap and our body. Since the mousetrap spring and body cannot be altered in any way to allow for a great amount of tension, having the lightest possible vehicle will help us get the greatest distance with constant force. Right? Next slide. Okay. Newton's Newton's law states that for every action there is an equal and opposite reaction. All this means is that when you have an active and reactive force between two objects such as people, each will be equal or the opposite. The same concept occurs when you push someone and you tend to move backward yourself. This concept will also apply to the mousetrap car since the mousetrap spring will have a lot of built-up tension directed in the opposite direction that we would like the car to move in. As the tension is released, the car will move forward.
Our objective for this project is to achieve as much forward motion as possible, whether it is on a flat surface or on inclined surface. This objective can be measured by how far our mousetrap car can move. The second one is to design, build and test a mousetrap car using the engineering design process and identify a problem. If there is a problem, we will develop a new idea and design to produce a new working mousetrap car. And the third one is to maximize the distance traveled on both the surface. To make sure that the objective can be achieved, we must keep our mousetrap car's weight and friction as small as possible.
So I will present about modeling and simulation. This is the examples of materials that we will use to make a mousetrap card. First, we will need to have a mousetrap, 4 CDs, black foam cord, 4 zip ties, straw, wire cutter as extrude blade, cardboard, and 2 BBQ skewers. Many different types of materials can be used in the construction of a mousetrap card. This is a very simple and cost-effective examples. Include of first for body, we will use balsa wood, basswood, styrofoam, plastic, and aluminium. Second for wheels, we will use 4 CDs, hobby wheels, and foam wheels. For snapper arm, we will use wooden dowel and metal tube. For axle, we will use wooden dowel, metal tube, and plastic rod. For string, we need to have calibrated fishing string and craft string, and miscellaneous, we need to have wrist spacers, string hook, ball bearings, balloons, spool tape and glue. And lastly, and of course, we need to have mousetrap. And this is the picture of all the materials that we need to make a mousetrap, which is the cardboard, straw, make mousetrap, as actual blade, BBQ skewers, platform cord, CD, zip ties, and wire cutter.
So next, I'm going to show you guys the procedure of the making of mousetrap scarves. Okay, so there are 8 steps that we must follow in order to make the best mousetrap cars, the functional mousetrap cars. Okay, so the first step is you have to remove the hold down bar from the mousetrap. Okay, but make sure you have the mousetrap first, okay? So I'm going to show you the hold down bar. Which one is the hold down bar in mousetrap? This is the hold down bar in mousetrap, okay? Okay, when you cut it, make sure you don't throw it out, okay? Because we will use it later. Okay. So next, using the wire cutters, you have to cut the lever, leave only one side, so that the lever is the metal piece that threads to the spring. So do not cut the spring lever, okay? And then you have to cut piece of wooden skewer into 8 pieces, and then attach the skewer to the cut piece of lever on the mousetrap using 2 zip ties. Okay, and after that you have to trim the zip ties, but make sure that the zip ties are fastened because we have to strengthen the mousetrap. Next, second step is, okay, you have to position the mousetrap so that the end of the trap is lined up with one end of this cardboard. Okay, I'm going to show you how it's going to be. Okay, so this is how your position of mousetrap car. This stick you have to line in same line as the cardboard. Okay, then you have to use a strip of tape to attach the mousetrap to the cardboard. Okay, and using 2 zip ties, secure the mousetrap, and then you trim. On the opposite end of the cardboard, measure 1 inch from each edge. Then you connect these marks with a triangle that cuts inwards towards the mousetrap. Okay, the third step. Okay. Use scissors to cut 2 wooden skewers into 5 pieces. And then you find a piece of metal that you trim off the mousetrap and make sure that it's long enough to bend. Okay, make sure that it is 90-degree angle with a hook on one side. Next, you tip the piece of metal to the middle of one piece of skewer. Make sure that the straight side is pointing straight off the skewer. Step 4, you have to cut piece of drinking straw into 4 pieces. And then tape the 2 of the straw pieces onto the end of the cardboard near the mousetrap. Okay. Put other 1-inch straw piece onto each end of the skewer with the hook. Then tape the straws onto the triangle side of the cardboard. The hook should be aligned with the cutout triangle. Right. Step 5. You have to cut the cardboard into 8 diameter circles. Okay, and then place a cardboard circle on the middle of each side of 4 compact discs and tape them in place with strong tape. After that, you can push a wheel onto each side of the axles. Okay. Step 6. Okay. You have to measure the ribbon from the end of the skewer to the metal piece on the opposite axle, and then you cut it. So you have to use tape to secure the ribbon and make sure it is secured very well, right? And then you tie a loop in the loose end of the ribbon. And, okay. Step 7. You put the loop of ribbon around the metal piece of the front axle, and holding the ends of the front axle, wind the ribbon towards you. Okay? Because this will pull the lever and skewer towards the back of the car. Then your car is ready.
Variables and controls. When building a mousetrap car, there are a number of variables to consider. Okay, first of all, weight of the car, placement of the mousetrap, length of the snapper arm and the string, size and type of wheels, and the last one is wheel to axle ratio. Okay, for weight of the car. Okay, in general, you want to build the lightest vehicle possible, right? Because it will provide less force to begin and less frictions. But your design decisions will depend on the goal of your car, whether you want a car with more distance, accuracy, or power. Okay, placement of the mousetrap. For distance cars, okay, place the trap farther from the axles. Meanwhile, for power cars, place the trap closer to drive axle. Length of the snapper arm and the string. For distance car, try a long arm. Longer arm will provide less force. Meanwhile, for power cars, try a shorter arm. Shorter arm will provide more force. For the controls, for all cars, the lever arm should just reach the drive axles, okay, to form a 90-degree angle, allowing for maximum torque. For distance and power cars, the string length should be a little shorter than that. Meanwhile, for accuracy cars, okay, the string can serve as braking mechanism. Size and type of wheels. For distance car, larger wheel will cover more distance per rotation. For accuracy and power cars, okay, you can increase the traction by covering the edge of the wheels with a rubber band on the middle of a balloon. Size and type of wheels for controls. Okay, for all cars, wheel alignment is very important. Okay, for distance and power cars, misalignment wheels can cause the car to leave the track or ramp. For accuracy cars, even a slight misalignment can cause your car to miss its target. And the last one is wheels to axle ratio. For distance cars, a large wheel to axle ratio is the best. Meanwhile, for power cars, a small the wheel to ratio is the best.
Okay, so I'm going to proceed with the next presentation, which is theory explained. So as we know that Mousetrap car, there is so much physics principle that apply on this Mousetrap car. But in this project, we focus more on principle of force and motion in explaining the motion of Mousetrap car. So we will focus more on Newton's law. So Newton's law is divided to three. First, Newton's law, second Newton's law, and third Newton's law. So in this project, we use formula F net is equal to MA. So where F net is equal to force applied on a mousetrap car, M is equal to mass of mousetrap car, and A is equal to acceleration. So Newton's first law applies to the performance of our vehicles in that we must remember that the car has inertia. Okay, so we need to remember that every object that has mass, they will have inertia. So those will tend to stay at rest when they at rest, or they will stay in motion when they in motion. So we need to make our vehicle inertia work to our advantage by getting it to stay in motion so that it can travel the longest distance possible. Okay, Newton's second law applies to the performance of our vehicle in the way that the second law states that the acceleration is directly proportional to the net force but inversely proportional to mass. So in order to get our vehicle to accelerate to a good speed, we need to make sure that the Mousetrap level steering system outputs the greatest amount of force possible. So the car also needs to made up from minimal mass. For the Newton's third law applies to the performance of our vehicle as it explains the relationship of force between the vehicles and the surface it must travel across. So in terms of Newton's third law, which state that to every action there is an opposite and equal reactions. So the wheels of the car push against the surface while the surface push back on the wheel, which then allows the vehicle to push forward while friction acts in the opposite direction. So a gravity and normal force keep the vehicles push along the wherever surface it is placed upon.
This is our schedule and guideline that we follow to complete our task for Apex project. There are 3 phases. For the phase 1, which is from the week 1 to week 5, that already passed. We do some discussion, brainstorming the project, prepare a slide and do a presentation of Apex proposal. So after this, for the phase 2, for the week 6, we will design a model. For the week 7, we will purchase materials. For the week 8 and week 9, we will set up and build the module. And for the week 10, we will run an experiment. And lastly, for the phase 3, we will improve the project in week 11. For the week 12, we will redo the experiment. For the week 13 to week 14, we will do discussion on our results and finalize the project for the day of Apex, which is in week 15. That's all.
For the last part of this project, I will explain the contributions of this project to us as a student. Okay, first and foremost, the contributions of this project is student will build an understanding of energy that being converted from one form to another. Okay, let me give an example. As one let go of the mousetraps, 2 energy transformations will occur. First, potential energy converts into kinetic energy as the car gains speed because the kinetic energy increases when the velocity is increased. At the same time, the kinetic and potential energy are converted into heat due to frictions, which is why the car will eventually come to the complete stop. When the car is complete stop, all of the energy has converted from potential and kinetic into heat. Okay, the second one, we will know that mechanical energy that's stored in the spring will convert it to energy of the motions. The third one, this project makes students close the loop between physical principle and it also makes students understanding of their car speed and distance performance. Okay, the fourth one, which is the last one, this project have made students understand the law of physics even better. I think that's all from us. Thank you.